HS science, we are going to talk about elements and compounds. But before we talk about that, just to refresh your memory on what you have done briefly, I'm sure you recall the teacher's definition or the definition of matter. You were told that matter is anything that has mass and can occupy space. You were told that matter is made up of very tiny particles which the eyes cannot see or which are very invisible to the eyes. Good. And such particles we say are made up of atoms, molecules, and ions. So today we are going to focus on one of them, which is atom. So when we say, an atom is made up of 3 subatomic particles. So an atom has what we call 3 subatomic particles. And these subatomic particles, one way I help my students to remember them very easily is to use the acronym PEN. So the acronym PEN for the subatomic particles, I have P, E, and N. Now my P here represents what we call protons. This is electrons, and this is neutrons. Good. So if you want to remember the subatomic particles of an atom, you can use the acronym PEN, which is protons, electrons, and neutrons. Alright, now the atom, which we say is the smallest particle of an atom has a nucleus. So let me write it here. An atom has a nucleus. Good. Now, out of these 3 subatomic particles, 2 of them are located permanently in the nucleus of the atom. And the 2 out of this is what we call protons and neutrons. The 3rd subatomic particle, which is electrons, the electrons are found on what we call the shell. So there's a shell that orbits the nucleus of the atom. When I say orbit, it moves around the nucleus of the atom, and that is where the electrons are located. So electrons are found on the shells of an atom. Good. Now, these protons, electrons, and neutrons come with charges. Proton, we say, is positively, so let me write it well, positively charged. An electron is negatively charged, and the neutron has no charge. Good. So let's look at a diagram of an atom. So we said an atom has a central part which is called the nucleus. So this is the nucleus of an atom. And out of the 3 subatomic particles, I've said that 2 of them are found in the nucleus, which is the protons and the neutrons. We said that the protons are positively charged and the neutrons have no charge. So we are going to indicate them there. So this will be my proton. This is my neutron, no charge. This is my proton. This is my proton. This is my neutron. This is my proton. This is my neutron. So this is called the nucleus. This is the proton. And this is the neutron. Orbiting this nucleus is what we call a shell. So this is a shell. And the shells contain what we call electrons. So the electrons are located on the shell. So this is my electron. So if I look at this atomic structure, you can see clearly that it contains protons which are positively charged, neutrons which are low charge, electrons which are negatively charged, negative charge, and it has a shell where the electrons are located. So these are very basic information that you should know about an atom. Alright, now having spoken about an atom, let's move on to elements. When we say an element basically is made up of 2 or more atoms of the same kind. And so I can use the term atom or elements to mean the same thing, because elements are made up of 2 or more atoms of the same kind. There are basically about 118 elements existing. At our level, we are going to focus on only the first 20 elements. Now, elements, like as I said, are made up of 2 or more atoms of the same kind. Elements are represented by what we call chemical symbols. These elements can be found on what we call a periodic table. Now, why chemical symbols? This is to allow for easy communication among scientists around the world, so that the scientist in Ghana, when he sees a symbol of hydrogen, for instance, it's the same thing for a scientist in China. So we use chemical symbols to represent elements. So for instance, let me take the first element, which is hydrogen, represented by H. Now, there are 2 ways we can get the chemical symbols. We get them by taking the first letter of the name, the English name of the element, or the second way is we get them from the Latin name of the element. So for instance, if I take hydrogen, the first letter is H, so the chemical symbol for hydrogen is H. If I take chlorine, the chemical symbol of chlorine is Cl. Now here, we are using 2 letters from chlorine. So the very first letter should be a capital letter, and the next letter should be a lowercase letter. So we are saying chlorine as Cl. Let us take an example of an element whose name is derived from the Latin name. Let us take natrium. This is natrium, and this is the Latin name for sodium, and so the chemical symbol is Na. You realize that the name is sodium, but the chemical symbol does not start with S, but it is Na because we take this from the Latin name natrium. So the first 20 elements which we are going to focus on at our level derive their names either from the English name of the element, where we take the first letter, or we take 2 letters from the element with the first one written as capital. If the symbol of the element is just 1 letter, we write it in capital, like hydrogen, so it's written as H. If it is, we are taking 2, then write the first one as a capital letter and the other one as a lowercase letter. Then from the Latin name, you will realize that it has got nothing to do with the English name. Another example, let me add, will be carrion. Alright, so another element whose name is derived from the Latin name is kalium. Kalium is called potassium. But you see that the chemical symbol for potassium is K, because it is derived from its Latin name, which is what? Kalium. Alright, having spoken about chemical symbols, let's also talk about something important about an atom, which is what we call the atomic number. Now, don't forget I mentioned that in the nucleus of an atom, you can find protons and you can find neutrons. The protons are positively charged and the neutrons have no charge. So when we talk about atomic number, we are basically saying that the atomic number is the number of protons that you can find in an atom. The number of protons that you can find in an atom is what we refer to as the atomic number. Now, how do you determine the atomic number? The position of the element on the periodic table will give you an idea of the atomic number. Like I said, the elements are arranged on a special table called periodic table. And so when we arrange them, the position of the element on the periodic table will tell you the atomic number of the element. So you can look for a periodic table and study it. But let's take an example. For instance, hydrogen is the first element on the periodic table. And so because it's the first element, I will say that the atomic number of hydrogen is 1. Sodium is the 11th element on the periodic table. And so I'll say that its atomic number is 11. Potassium is the 19th element. And so I'll say that the atomic number of potassium is 19. So that's how we come about with the atomic number. Then let's also talk about neutron number. As the name implies, neutron number is the number of neutrons that can be found in the nucleus of an atom. So we'll also very soon we'll look at how to calculate neutron number. Then we'll also talk about electron number. Now, electron number is the same as the as the proton number in a neutral atom. The emphasis in a neutral atom. So if I tell you that an atom has atomic number 19, what is the number of protons in that element or that atom? It is 19. If I also ask you what is the number of electrons in the atom or element, it's also 19 because the element is a neutral atom. We'll come to atoms which are not neutral in the subsequent lessons. But for now, the number of protons and the number of electrons are the same. But the number of protons and the number of neutrons are not the same. And very soon we'll look at how to calculate that. So if I want to indicate the atomic number of an element on the symbol, for instance, if I take potassium, it is written as a subscript at the left hand side of the element. So this is atomic number. So if you see any element, you pick your periodic table and you see an element with a subscript, a number written here, then this is how we identify our atomic number. You will not see the electron number on the element, but you can find that from the atomic number. You will not see the neutron number on the element, but we will soon find out how we can calculate the neutron number of an element. Alright, now finally let's talk about another important aspect for this part of the lesson. We are going to talk about electron configuration, or what we call electronic configuration. Electronic or electron configuration. Alright, now I said that an atom has 3 subatomic particles: protons, your pen, don't forget the acronym, electrons, and neutrons. Out of these 3, I have said that protons and neutrons are found in the nucleus of the atom. The third one, which is the electrons, are found on the shells. Now, if the number of protons and the number of electrons are the same, then there is the need for us to arrange the electrons on the various shells. So the process of arranging the electrons on the various shells is what we call electronic configuration or electron configuration. So for example, if I take sodium, atomic number, now I hope you can identify it, atomic number 11. If I want to arrange this, then I have to draw my atom with a nucleus. So I have my protons and neutrons in here. Then this is my shell. So I'll arrange the electrons on them. Don't worry, very soon we'll know how the electrons are arranged. So let me just arrange them. Good. Then third one. Good. So the process of arranging the electrons on the shells is what we refer to as what? Electron configuration. Alright, so in our subsequent lessons, we will look at why I am placing 2 electrons on the first shell and why this is 8 and why this is 1. We will look at that in a more detailed lesson in our subsequent lesson. Thank you very much, and I hope you have enjoyed my lesson. I'll see you in the next lesson.